All right, so the product rule is that if we want to find the derivative, so d dx, of two functions that are being multiplied together, so say we're going to find the derivative of f of x times g of x, which is where the product comes from, because we're looking for the derivative of the product of two functions. This is going to be the same thing as, I'm going to use prime notation for the next part, so I'm kind of mixing up my notations. So this would be the same thing as f prime of x times g of x plus f of x times g prime of x. So they both end up getting a derivative. We've got f of x and g of x. They both get derivatives here and here, but we also have to include the regular function too. Now there's a proof of this that I could go through with you guys, but I'm not going to go through it today with you because I feel like the proof would just make you upset that I'm going over the proof. So for now, just take it on faith that the derivative of a product of two functions is f prime g plus fg prime. Okay? So I'm going to show you a simple application of this, and then I'm going to kick it up a couple notches, and I'll show you a more complicated application of this. So let's say that we have a function here that is, say, x to the fourth plus 3x squared plus 1, and we're multiplying that by 2x to the fifth plus 7, and I want to find the derivative of the whole thing. So I want to find d dx of that whole thing. Alright, so here's the easiest way that, or here's how I do it at least. I don't know if it's necessarily the easiest way. First thing I always do is identify which function's f and which function's g. So I'm going to say, just because that's how like alphabet works, I'm going to say f is on the left and g is on the right. You could reverse them and it'd be fine. So first I'm going to find out what f prime is, or the derivative of f. So f prime, or the derivative of f, would be 4x to the third plus 6x, and then the 1 goes away. G prime would be plain old 10x to the fourth. Alright, so I know what f is, I know what g is, I know what the derivative of f is, and I know what the derivative of g is. Right, so I'm going to do f prime times g, so 4x to the third plus 6x times 2x to the fifth plus 7. So this is f prime times regular g, and then I'm going to add to that regular f times g prime. So regular f is x to the fourth plus 3x squared plus 1, and regular g is 10x to the fourth. Now, I can simplify this more, so I'm going to do exactly that. So on the left-hand side here, if I FOIL this all out, I'm going to get 8x to the 8th, because I'm doing first times first. If I do outside times outside, I'm going to get plus 28x to the third. If I do inside times inside, I'm going to get 12x to the sixth. And then if I do last times last, it's going to be 42x. You guys with me so far? Okay. Now over here, I just have to distribute the 10x to the fourth to all three terms inside, and then I'm done. So this is going to be 10x to the 8th plus 30x to the 6th plus 10x to the 4th. And now there are some like terms in here that I can combine. So for example, for x to the 8th, I've got 8x to the 8th plus 10x to the 8th, so that's 18x to the 8th. I don't have anything to go with the third, but I'll deal with that in a second. I do have some plain sixes, so I'm going to do plus 12x to the 6th plus 30x to the 6th is plus 42x to the 6th. I don't have anything to combine with the x to the 4th back here, so plus 10x to the 4th. Don't have anything to combine with 28x to the 3rd, so plus 28x to the 3rd. And then, is it just this 42x that's left now?
Yeah.
Plus 42x. So that would be the derivative of this function.
It's just a lot of work.
Yeah, it's a lot of work, and you have to remember your exponent rules. So, I mean, I'm being honest with you. This isn't the easiest thing we've done this year. However, if you remember your exponent rules and you are keeping your work nice and neat, it shouldn't be too bad. If you tend to be a little messy with your work, maybe you might want to try to make an effort to tighten it up for today's stuff. Yeah, sure. So I had my function here, this whole thing. And because it's one times another, because I have two things that are being multiplied, I can say that this function here is f of x, and this function here is g of x to match my setup up here. Now, the first thing I did is I took my f of x, and it doesn't matter which of these you call f and which you call g. I could have flipped them, and that would have been fine. Because you'd end up with the same thing over here, just flipped, but then since you're adding, it doesn't matter. Okay, so I took my f of x, which is this. I found the derivative of that, so that's going to be 4x to the third plus 6x to the first, and then the 1 goes away. The derivative of g is 10x to the fourth, and the 7 goes away. And now when I set it up here, I did f prime, which is this, times a regular g, which is that, plus regular f times g prime. And then I just multiplied everything through and combined my like terms. So, yep. So let's take this up. I don't know how many notches, a number of notches. We're going to look at a more difficult example. Because you guys don't hate me yet, and my day isn't complete unless you feel anger towards me. Okay. So let's throw in what we learned on Friday about rational exponents into this. No, and yet. So let's say that we have a function here, y is equal to 5 times the cube root of x times, in parentheses, 5x to the fifth plus 1. Okay, so I've got function f on the left, function g on the right. And again, it doesn't matter. You can flip-flop those if you want to. The first thing I'm going to do is find out what f prime is, and then I'm going to find out what g prime is. So for f prime, I need to remember that the cube root of x, this is the same thing as 5x to the 1 over 3 power. The 1 comes from the power of x inside the radical, and the 3 comes from what type of root it is. So cube root of x is really x to the 1/3 power. Kind of, sort of? Okay. So now, if I'm finding f prime, I'm going to knock 1/3 out in front and multiply it by 5. 1/3 times 5 is 5/3. It's going to be way easier if you leave these in fractions than if you try to make them decimals, because that would be 1.6 repeating, which is nasty. And then we're going to knock the power of x down by 1. So 1/3 minus 1 makes negative 2/3. Okay? Now, x to the negative 2/3, this is really 1 over cube root of x squared, right? Because this is the power of x, this is the type of root, and then the negative means it needs to go on the bottom of the fraction. So the way I'm going to write it, I'm going to write it as 5 over 3 times the cube root of x squared. So that's really what f prime is. You guys with me so far?
Yep.
Okay, I heard a no. Okay. Now again, this is considered sloppy in math, to have a square root or to have any kind of root in the denominator, but for now we're going to make an exception to the rule. So now if we look at what g prime is way easier.
You're right.
So g prime is 25x to the fourth and nothing else. All right. So setting up, finding out what the derivative of this is, we have to do f prime times g plus f times g prime. So f prime times g, that's going to be 5 over 3 times the cube root of x squared. And then I'm going to multiply that by 25x to the fourth. And then I'm going to do plus. Oh, thank you. Good Lord, you guys are awesome. So 5x to the 5th plus 1. Mr. Daft. Seriously. Okay, and then this one, I'm going to do regular f. So 5 cube root x times g prime, which is, this is where the 25x to the 4th comes from. Cool. Now, okay.
Well, you can put the stuff over 1, so then it's just...
Right, so let's deal with what we can do about this. Okay. No, let's deal with this. So we're going to deal with the easy part first, the right-hand side. So this is the same thing as x to the 1/3 power, right?
Yeah.
What's 5 times 25?
Or, 125.
There, 125. And then x to the 1/3 times x to the 4th is going to be together
4 and 1/4. So
4 and 1/3,
13.
which is 13/3. X to the 13/3 power. We'll deal with that in a second.
So bad.
Don't worry, we'll deal with that in a second. But now we've got it down to just one term. Okay. Over here, we're going to have to distribute this to both things inside the parentheses. So this is going to become 25x to the 5th divided by 3. And I'm going to change this back to x to the 2/3 power for what we're going to do for the next step after this. Plus, and then this is going to be 5 over. Okay, is that better? So 5 over 3 times x to the 2/3. Okay, so let's, how do we want to go about this?
I don't know.
Let's add those together.
Well, okay, so these two have common denominators, so we can add them together nice and neatly.
25x
So 25
over 3x.
x to the 5th plus 5 over 3x. Don't worry, I'm going to give you guys some good news in a second here.
Oh, okay.
There is no solution.
No, there is a solution. There super is. 125x to the 13th power, and it's
25x.
25x to the 5th comes from doing 5 times 5x to the 5th.
Is that,
Okay,
is that 3 to
But-
the,
this is 3 times the cube root of x squared. Okay, here's the good news. All right? All I'm grading on the assignment is if you can get it this far. Okay? If you can get it this far, you'll get full credit on the assignment. If you can get it this far correctly, then you get bonus points.
But this is the final.
Yeah, this down here.
Oh my god.
I mean, we could go further because we still have a root in the denominator. But yeah, that's as far as we can go. So this, if you can get it this far, you're good. Full points. If you can get it this far, bonus points. Kind of, sort of? All right. Let's take a look at your assignment. We're going to go through some of these together. Maybe. I got a bunch of copies that weren't mine. I forgot to title the assignment, so it just says assignment.
Yeah.
Okay, so we just did question number 3 together.
I didn't really. You're right.
So let's go through one of the harder ones first. So let's take a look at maybe 8. 8 looks pretty hard.
Oh, yeah.
9 looks pretty hard. And 10 looks pretty hard.
they all look hard.
No, you're right. You're right. I'm using the wrong nomenclature. 8 looks harder than most. Because if I say that 8 looks hard, that means that the rest look easy.
Yeah.
I'm with you. Okay, so let's take a look at question number 8. All right, so we've got our f here. We've got our g here. So the first thing I'm going to do is find, so f prime, the derivative of f. I would knock the 2/5 down in front, multiply it by -5. and that would be negative 10 over 5, which is negative 2. And then x is going to be raised to 1 less than 2/5 as its power. Okay, negative 3/5. Now I'm going to go just a step further here. Turn this into negative 2 over the 5th root of x to the 3rd. Kind of sorted so far? All right. Next, I'm going to find out what g prime is. So g prime is 4x to the 3rd. All right. So now I'm going to do f prime times g plus g prime times f. So f prime is negative 2 over the 5th root of x to the 3rd. That's f prime times g, x to the 4th plus 3, plus plane f, negative 5x to the 2/5 power, times g prime, which is 4x to the 3rd. If you can get it this far, full points. Okay? If you can get it this far, full points. However, it can be taken further. But I'm running out of room on my paper here, and I told you it was bonus points, so I'm not going to take it further. Well, I already gave you, like, if you just write down what you did in your notes on number 3, you already get 1 bonus point. And I can guarantee you there's at least 3 people in the room who won't do that. I can almost promise you.
What?
Don't worry about it.
I already circled what you're up.
All right, let's look at number 10 here. Okay? So number 10, I'm going to call this F. I'm going to call this G. And you can absolutely switch these. If you want the first one to be G and the second one to be F, that's fine. It makes no difference. I just put F first because that's how alphabetical order works. So F prime, I have to understand that this is really 5 times x to the 2/5 power. So F prime is going to be 10 over 5, which is 2, x to the negative 3/5, which is really 2 over the 5th root of x to the 3rd. So there's F prime. G prime is nice and easy. What's G prime, anybody? 16x to the 3rd. Cool. Now, from here, we're going to do F prime times G plus F G prime. So F prime times G is going to be 2 over the 5th root of x to the 3rd times 4x to the 4th plus 4 plus 5 times the 5th root of x squared times 16x to the 3rd. So if you get it this far, full points. If you take it further, bonus points. Okay? But you only have to get it this far to get full points. Now let's take a look at least one on the backside here. Because you guys are going to look at the backside and then be mad. I know. I know. I watched me do it. Believe me, I know.
This is easy though.
Yeah. I watched me do it, so I know. Let's take a look at, yeah, I know. Let's take a look at number 12. So first you got to find the derivative so that you can find out what the slope of the line tangent is. So first we're going to do the derivative of this, which is going to be 1/3 times x to the, thank you, negative 2/3 plus 2. We're going to have to substitute 3 in for x here. This is why we enslaved an entire race of machines. I know. It's much easier to use your calculator, you're right.
Isn't there a way to take this further?
Yeah.
Yeah, no, we super can, but
Oh, I see it.
since we just want to substitute the x value in now to find the slope, we can stop here. We don't have to go any further. See what I'm saying? Because now, if you type this into your calculator, you can do 1/3, and then we're going to do, instead of x, we're going to put 3. So times 3 to the, in parentheses, negative 2/3 power, plus 2. And there we go. We'll approximate that to 2 decimal points, and that'll be our slope. So m equals about 2.16. And then we'll use that for everything else. So we'll do y minus 2 equal to 2.16 times x minus 3. And so 2.16 times 3 is that, and then minus 2. So y equals 2.16x minus 4.48. Oh, you guys didn't even see that. Come here. And there you go. Kind of, sort of. The ones that are hard, I think, on the backside, or I'm sorry, the ones that are more difficult than the average on the backside.
The ones that were 20.
11, 12, maybe 18, and 20. Those, well, no, I guess
18's not
13, 15, 16. Those aren't that bad because there's not a huge amount to it, especially if you're using your calculator to approximate. Number 20, do you guys remember what the derivative of e to the x is?
Yeah.
Right, so that would just be e to the x. And then put negative 3 in for x.
Wait, what?
What's the derivative of e to the x?
X times.
E to the x.
Why is it even that?
It's a rule.
We can go through a proof of that, but I didn't want to go through
No,
a
but
proof.
I don't think I heard you when you were talking about
Yeah,
that.
it was in Mrs. Comble's room. I was at the front of the room. You were towards the front to the right.
Oh yeah, I was probably listening to music and
Okay.
looking at that.
Okay. There's a whole rule for what the derivative of e to the x is. The derivative of e to the x is e to the x.
That's right.
And yet,
Oh, maybe.
I was about to
Mine
prove
was
it.
like 5, and I was
Yeah,
like,
okay, I do have that written down. I just never look at it. I always look